Hi everyone, so welcome again to another tutorial, and in this video we're going to talk about one of the basic concepts in mathematics, which is known as the sets. Without further ado, let's talk about how set is defined in mathematics. And in math, set is known as a group or collection of a well-defined and distinct objects. So technically, we're just talking about a group of objects here. But we must take note of these two important criteria for us to determine whether a certain group should be considered as a set or not. So the first one is being well-defined. So the members or the objects should be well-defined. What do we mean by well-defined? So it refers to a specific property which makes it easy for us to determine whether a certain object is a member or not. The second one is distinct objects. The objects or the members should be distinct or different from each other. Now let's find out if the following examples of group or collection of objects can be considered as a set or not. Let's have this first example. We have a group of planets in the solar system. Can we consider this as a set? Let's find out. Now in this group, we are sure that the members or the objects which belongs here are the following. We have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. Which means to say that it is easy for us to identify the members or the members are well defined. And aside from that, if you will notice, the objects or the members that we gathered here are unique or different from each other. So therefore, this one or this collection can be considered as a set. Now let's have another example. Let's say we are given a group of beautiful girls. Can we also consider this as a set? Let's find out. Now it is possible for us to determine a member of this group. However, it is not clear onto which are really the members of this group because we might come up with different answers since the term beautiful is subjective. What do we mean by subjective is there might be an instance that member is beautiful for you but not for me based on my interpretation. And also the other way around, the member I listed might be beautiful for me but not for you. So there is a contradictory in terms of naming a member of that group. Therefore, it is not well defined and therefore we cannot consider this as a set. Let's have one last example. Let's say we are given a group of colors in the rainbow. Now, upon hearing the colors in the rainbow, we are sure that there are 7 colors included. And these are the red, orange, yellow, green, blue, indigo, and violet. Which also means that the members are well defined or we can easily identify the members. Therefore, this one is considered as a set. So we can now say that this is the set of colors in the rainbow. Okay, so we have just learned how to identify whether a given group is a set or not. This time we're going to learn how to name or how to denote a given set. Now a set is usually denoted by a capital letter, while its elements are denoted by small letters. Let's say for example, we are given a set of vowels in the English alphabet. Now here we are sure that the members included here are A, E, I, O, and U. Now how are we going to write this one in symbols? So let us denote this set as set V. So we will use the capital letter. Set V containing. Now take note of how I read these braces. We use these braces to mean that everything inside this are included in that given set. So it is read as containing or contains. So we will write inside all the members which are A, E, I, O, and U. And these members are also known as the elements. In symbol, we use this kind of symbol to denote that an object is an element, while this one if it is not an element. So let's say, for example, here A is an element of set V. E is an element of set V. However, C is not an element of set V. So that is how we represent or how we show in symbol whether an object is an element or not. Now this time, let us be familiarized with the properties of set. So here we have two properties that we need to take note of. And the first one is, it says here that the change in order of writing the elements does not make any changes in the set. What does it mean? Let's say, for example, we have set A containing 1, 2, 3, and 4. Now, whether I write this as 2, 3, 1, and 4, or 4, 3, 2, 1, it doesn't matter. It is still representing the same set, which is set A, to mean that the order of the elements inside your braces does not matter. So that's it for our first property. Now, let's have the second property. For the second property, it says here that if one or many elements of a set are repeated, we considered it as a single element. Let's say, for example, we have a set of letters in the word mathematics. So if you will notice, there are certain letters which are repeated, like A, M, and T. Now, how are we going to write now the members or the elements? So let us denote this as set M. Now since again M, A, and T are repeated, so we'll just use 1 to represent these elements. So we will have now M, A, T, H, E, I, C, and S to be the elements in the set M, which are the letters in the word mathematics, wherein the repeated letters M, A, and T are just used or are just represented by a single element. Alright, we're now going to talk about how we represent set, and there are two ways which are commonly used in representing a set. So the first one is known as the roster method. In this method, elements of the set are listed within the pair of braces and are separated by commas. So let's say, for example, we have a set of first 5 natural numbers, and let us denote this by n. So n will be the set containing 1, 2, 3, 4, and 5. So if you will notice, this is just the same way as what we did a while ago in our previous example. We are just merely listing the elements included, separated by commas, inside these braces. Let's have another example. Let's say we have a set of all odd numbers less than 9. And let us denote this by x. So x, let's make it look bigger. So x will be the set containing the odd numbers less than 9. So those are 1, 3, 5, and 7. Now this is just how we do the roster method. Now different thing will happen for the second method, which is known as the set filter notation. In this case, the elements of the set are represented by a variable, let's say x, which is followed by colon or a straight line, which is read as such that. So these symbols, colons, or this straight line are read as such that. Now after this, what you will do is to describe your variable or the variable that you use in such a way that this will represent all the elements included in that set. So how are we going to do this? Let's say, for example, we have set P containing the elements of counting numbers greater than 12. So we will have set P containing x such that, let's describe now x. X is a counting number greater than 12. Meaning to say, any number that will fall in your definition of x, which is a counting number greater than 12, is already included in your set P. And those elements are represented by x. Okay, let's have another example. Let's say we have set A to be the set of even numbers less than 100. So we will have set A set A containing y, this time let's use y, such that we can use this symbol or colon, any of the two will do. So we'll have y such that y is an even number less than 100. So by our definition of y, so technically or definitely all those numbers, all those even numbers less than 100 will fall under this set A. So that is how we do set builder notation. Okay, now this time let's talk about another concept of set, which is named as the cardinality of a set. Now, how do we identify cardinality of a set? Now, let's say for example, we have a set A, which is the set containing 1, 2, 3, 5, 7. Now, cardinality is denoted by n parentheses the name of the set. So this is read as cardinality of set A to be the number of elements that you have in your set. And in this example, we have 1, 2, 3, 4, 5. 5 elements. So therefore, the cardinality of your set A is equal to 5. So that's it. As simple as that. Now let's have another one. Let's say for example, we have set B. Set B containing A, B, C, D. Now here, how many elements do we have? So here we have 4 elements. So therefore, the cardinality of set B is equal to 4. Now we will use this idea later once we move to the different types of sets. Null set. Null set is a set which does not contain any element. And here we use the symbol or a braces with no elements inside to indicate or to denote an empty set. Example for this is the set of whole numbers less than 0. We are sure that there are no whole numbers less than 0 because whole number starts with a 0, 1, followed 2, and larger numbers. So technically, there are no whole numbers less than 0. So therefore, this is an empty set. For the second one, we have finite set versus the infinite set. Now, based from the name itself, finite set, the number of elements here are definite. Let's say, for example, set of colors in rainbow. There are 7 members. Set of days in a week. There are also 7 members here. While on the other hand, for infinite set, these are the sets which are containing never-ending elements. Example of this are set of all prime numbers. Since numbers are never-ending, so we cannot identify all the numbers or all the prime numbers included in this set. Another example, set of all even numbers. So there are never-ending even numbers as well, like the prime numbers. So therefore, this is an infinite set. And in naming an infinite set, we usually use the set builder notation since we cannot list down all its elements. For equivalent sets, two sets are considered equivalent sets if its cardinality are equal. So let's say, for example, the cardinality of set A is equal to the cardinality of set B. So let's say set A is the set containing 1, 2, 3. So therefore, its cardinality is equal to 3. While for B, set B, let's say it is containing P, Q, R. So therefore, the cardinality of set B is equal to 3. So since their cardinality are just equal, there we can conclude that set A and set B are equivalent sets, and it is written as in symbol set A is equivalent to set B. While for the equal sets, we say that two sets are equal if it is containing the same elements. Let's say, for example, we have set A containing P, Q, R, and S, while set B is containing P, S, Q, and R. Here, the elements contained in both sets are just the same. Therefore, we can conclude that set A is equal to set B. In addition, in the concept of sets, we are also using these terms, subset and proper subset. And how these two differs, let's find out. So for subset, it says here that if A and B are two sets, and every element of set A is also an element of set B, then A is called a subset of B, and we write it as this way. A is a subset of B to mean that A is contained in B, or we can also say that B contains A. So that is the two ways to show that a certain set is a subset of another set. It says here that if A and B are two sets, then A is called the proper subset of B if A is a subset of B, but B is not a subset of A, or there is at least one element of B that is not in A. Now let us apply this concept of subset and proper subset through this example. Let's say we have set A containing 1, 2, and 3. Set B containing 5, 6, and 7. While set C containing 0, 1, 2, 3, 4, and 5. Now here, we can conclude that A is a subset of C, since all of the elements of A is in C. And we can also say that A is a proper subset of C. Why? Because there are at least one element, actually there are 3 elements of C which is not included in A. So we can say that A is a proper subset of C, and we use this symbol for proper subset. And for the last one, we can say that B is not a subset of C, since not all the elements of B are included in set C. Now there are still things that we need to remember about sets. So here are the followings. First one is, any set is considered to be a subset of itself, or A is a subset of A. As an example, no set is a proper subset of itself. The empty set is a subset of every set. And the empty set is a proper subset of every set except for the empty set. Now for the last concept we are going to tackle about, that is known as the universal set, and it is defined as the set containing all the elements present in the sets being considered. Say for example, let's say we have set A containing 7, 9, 6, 10. Set B containing 1, 9, 7, and 13. Set C containing 8, 5, 10, 14. Now for universal set is denoted always by capital letter U, and it contains all the elements present in our given set. So here we have 7, 9, 6, 10, 1, 13, 8, 5, and 14. So this now contains our universal set. Let's have another example. Let's say we have set B containing A, C, B, Z, M. Set J containing B, C, E, F, G. Now we will list down all the elements present in both of these sets, since these are the sets that we are considering in this situation. So our universal set will be A, C, D, and E, J, M, B, F, and G. So this one now contains all the elements in both set V and set J, and that will be our universal set in this situation. So that will be all for the discussion of the basic concepts of sets in mathematics. I hope you learned something from this video. Thank you for watching.